So some of these students clearly are doing better than other students. So maybe we should try and find a way where they can help each other, so that they can pull each other up.
So students tend to anyway study in groups, pairs. So two students may decide that they can get together and study together, and usually when they get together in pairs like that, one student is able to help the other. One is better than the other in something, and so is able to help the other student.
Yeah, so I think we should not get into a situation where one student is clearly better and feels somewhat superior. So maybe
superior or just he feels doesn't getting anything out of it, right? So he's spending all the time helping the other person.
Yeah. So
it would be good if you can find a pair of students in a study group where each person is able to help the other in something. Let us say first student is able to help the second student in one subject. The second student is able to help the first student in another subject.
So you want a thing where, say, one student has higher maths marks and the other one has, say, for example, higher physics marks.
That might be a good one. So
then they can both get something out of it.
Both something. So first student can help the second student in maths. Second student can help the first student in physics.
Okay.
That way they help each other.
Okay. So how would we find such pairs, for example? So we want to find students who could be paired up. So we could suggest to them that if they work together, they might be.
So we are actually looking for pairs of students where the maths marks of the first student is significantly higher than the maths marks of the second student, where the physics marks of the second student
are significantly
higher than the physics marks of the first student.
Okay.
We're starting with maths and physics. Of course, we can do this for other subjects.
Yeah. So let's say we do it for maths and physics. So so we want this kind of opposite.
But you know what, if the maths marks of the first student is more than the maths marks of the second, physics marks of the second student is more than the physics marks of the first, then it's likely that the maths plus physics of both.
So one is high, one is low in both cases. So they might have similar maths plus physics.
Sums, right? The totals may be similar.
And also if we find people who have similar totals, their abilities are also probably
roughly similar, right?
Similar.
So should we look for that? So should we look for similar? So look for similar totals. So in fact, actually, if you are doing similar totals, then to pick a student, we don't even need to compare two cards. So you can take one card with some total. Let us say 200 is a total, and if the person has a high math score, must have a
because you cannot
correspondingly lower physics score, right? So just pick some two people with similar totals in which one person has a high maths mark, the other has a high physics mark. That should be enough, I think.
Okay.
Isn't it?
Yeah.
Something like that. Looks like a heuristic.
Right. So now we need to find pairs which have similar totals.
Similar totals. How do we do that? Binning.
Probably, because otherwise we'll have to again compare everybody's total with everybody others, and then so maybe we should put the totals in some categories and then look within those categories. So we could probably decide maybe
30 cards. So should we divide into, say, 6 bins? Is that 6?
By
6 bins.
I think it's unlikely anybody has got less than 150 out of 300.
So 150 to 300.
Highest, probably nobody has got more than about.
Somebody's got 280, we thought, right?
Yeah, 280 or so must be the highest.
So 150 to 280. So it's like 180 marks. We divide into 6 bins.
130 marks. So
130 marks.
So maybe you can put in 20 mark bins. Maybe
20 mark bins will give you 6 bins.
Okay. So maybe we'll start at the highest level. So 280.
6 bins means each bin has 5 cards.
So maybe we'll start at 270 because I think very few students would have very high marks. So 270, 250, 230, 190. That we can make.
Do you want to make it 5 bins? Because that way you'll have 6 cards in each, it's easier to pair. Otherwise you'll have one odd card in the bin.
Fine. So what should we put as the highest bin now? Then 250. Then make 25 mark bins.
25 mark bins.
150, 175, 200, 225, 250, 275. Okay, so let's start with 150 and make 25
mark bins.
Okay.
Yeah.
Okay, so this is 250 to 275 bin.
Okay.
This is a 200 to 225 bin. This is a 150 to 175 bin.
Okay.
This is again in this 250 to 275 bin. This is a bin which comes in between these two, so we should probably shift it a little bit. So this is 175 to 200, or 176 to 200. This is 200 to 225, so this is the same as this bin.
This one.
188 is in the same bin as 189. 187 also is in the same bin. 227 is above 225, so we should put it in this bin. 276 is above 275, so this is, maybe we'll keep it down here as a 6. So these are now our 6 bins. I don't think we have any more new bins coming. This is below 225, so it should go in this bin. This is again between 200 and 225, so this is this bin. 247 is below 250, so it should go in this 4th bin. 281 is in the highest bin. Now 209 is in this 200.
So I would say that this particular bin, which is the highest bin, no need to
pair. They must be getting at least,
already doing well, right?
Yeah, an average of more than 90.
So we don't worry with that.
240 goes in the bin here. 244 is also in that bin. 254 goes in this bin. 219 goes in this bin. 216 goes in this bin. 227 goes in this bin. 174 is in the lowest bin. 224 is in the upper end of this bin. 181 is in the second bin. 196 is in the second bin. 198 is in the second bin. 250 is a borderline, but I think we are taking 251 probably, so we'll put it here. I think
Sure.
Then 210 will go in this bin. 240 will go in this bin. And 261 will go in this bin. So it looks like these 3 bins have the biggest numbers. As you said, the top bin probably is not.
We don't need to pair.
They don't require any help. They've got almost 90% or more and everything.
Okay, so we'll keep them aside.
Yeah. So let's just pick one of these. For example, let's pick this 198 bin. Right? So now what we are looking for, let's keep these bins carefully so we don't disturb them. So what we are looking for in this are people who have, say, high marks in one subject.
So what we said basically that because the totals are roughly the same. Of course, there are 3 subjects. We did total physics and maths. So we don't know whether heuristic will be correct or not. But our guess is that since the totals are roughly the same, if one person has high physics mark, the other person will have a high maths mark.
Yeah.
Something like that.
So let's do one thing. So maybe we can just group it into those who have higher maths than physics and higher physics than maths, because there should be 2 groups. Right? So this person has higher maths than physics.
Okay.
And this person has
higher physics and maths.
This person is actually equal. Okay. So this person is also higher physics than maths. This one is marginally higher in maths. This one is significantly higher in maths. Right. So now, for instance, this student and one of these two, maybe this student could possibly help each other.
So 74, 56, 78, 64. So looks like a good pair, right?
Yeah. So maybe
because there's good significant difference in the maths marks. So we could consider pairing these two.
Yeah.
Right? Consider. Okay.
Now here the difference is not much, and there also the difference is not much, but maybe these two
could be paired. 62, 52, 64, 45. Looks good. Okay.
So these are 2 reasonable pairs. Of course, now what we are doing is we are putting students who are doing not so well. But in a way,
it's all right, I think, because they will be
psychologically it might help.
Correct. And even though they are not doing well, like physics 78 is not bad.
Yeah. So we found 2 such things in this group.
Okay, let's try the others. Let's keep this aside.
These 2 we can say, we can pair them up, but it may not have any significant impact. So let's look at this one. So again, we do the same thing. So we keep higher in physics, marginally higher in maths, reasonably higher in maths, higher in maths, quite a bit higher in maths, higher in physics,
higher
in maths.
There are more here.
Yeah, so now there are more people with high maths marks. But again, if you look at this, there are 2 students who have a big difference between physics and maths, 80 plus and around 60. So we can look for people who have a big difference in the maths marks and try to pair them up. Okay, so nobody has such a significant difference, but at least with a higher difference. So this is 9 marks. This is quite a bit. So
76 and 50.
Possibly can go with one of them. So this is a good pair maybe. So we can pick up any of these.
So why is this a good pair? Because maths 76, 62 and here physics 81, 58.
Yes.
So very good pair, right?
Yeah. So roughly the total is the same. So they kind of are equally different in the 2 subjects. So now in terms of that kind of a difference, possibly we have, so this comes from that pile actually, 7. So is there a person we can pair with 88 and 63? Well,
this may be okay actually. 78, 63, 88, 69. Seems like okay.
Okay, so let's keep these two together.
Right? 78, 63 is big difference. 88, 69. They can help each other definitely. Yeah. Okay.
Now we have this person who has a marginal difference. Maybe we can take somebody who has a similar marginal difference. See, this is 72, that is 72 in maths and physics, and 64 in maths.
66.
And
yeah.
So these are
this may be
fairly
okay. Yeah. Reasonably good match. Yeah.
And all these three now have higher maths marks, so we'll just keep them aside for now. And this is the other biggish pile. So let us see. So now here again, physics is higher, physics is marginally higher, physics is higher, maths is higher, maths is higher, physics is much higher, maths is marginally higher. So here I think we can find some pairs. So if we look at
87, 64.
Yeah, so 89, 62. For example, any of these could work. So 89, 62 could work, or 87, 64 could work with this one.
Yeah, let's put it.
And let's take this pair.
So you see here, 92 can help 64, 87 can help 71.
Yes.
Yeah, seems okay actually.
And here we could take, say, maybe this pair. So one, they've got 80 plus in one of the subjects, and
yeah, 89, 74, 83, 62. Again, it seems to be a good pair. Yeah.
Now this is a bit marginal, but we could, if we want, pair these two.
74, 65, 76. Okay.
Physics is not really low, but they are at least of similar. Or we can just say we don't need to pair them.
Keep it for a moment. Yeah.
Okay. So these are the three big piles, and we have managed to find at least 5, 6
We
pairs.
found a lot of pairs actually.
So 6, 7 pairs. As we go higher up, again, it's not clear how much they need, because now if somebody's got 260, 250 plus, then maths, physics, so physics is higher there, maths is higher there, physics is higher here. These two have higher physics and these two have higher maths. So of course, at this level of achievement, probably these two are a good pair, 92, 93, 72, so we can probably pair them up.
High achiever pair.
High achiever pair. Here again, it's not that they're doing badly, but
They
there
could
is a
help each other.
significant difference between the, so maybe we can.
Maybe they can pair, yeah.
Okay. And now we said the highest one.
This
we're
one we
not
don't
going
need to.
bother. Lowest one we have 2, but both of them have done higher in physics, so there's not much we can achieve there. But we could possibly look at across now if you want to do that to the next group, for instance. So this is the first group, and this was the people we left
If
out.
they have roughly similar marks in maths and physics, we can look at chemistry. I mean, that is the other thing to do.
Of course, that's the other thing to do. So we can see if. So here, for instance, physics and chemistry, there is a natural pairing because there's 78 and 72 and 58 and 53.
Yeah.
So these two can help each other.
Help is in physics and chemistry,
Physics
right?
and chemistry. And these also, for example, this person can help in physics and in both, I mean in chemistry, and the person on the left
Maths
can
and
both
physics.
maths and physics. So maybe that's a good pair. We can put them together anyway. Now let's look at these three. Again, if there is. So this person is very weak in chemistry. This person is
good
decent
in
in chemistry, and this person is much better in maths.
Maths and
physics.
same
Again,
thing,
This
yeah.
might be a good pair. So we can pair them up. And now we come to these last. So let's see among these 4 if we can find a good pair. So there is a very weak chemistry mark here, and this person actually has higher maths marks than this.
So again, these two will be pairing.
But even here, this might also be okay because there is an even bigger gap in the maths marks.
Actually, this is probably better.
So probably we can choose that. And here actually this person is uniformly better. So in a sense, this is not a good pair from our perspective. So I guess this is inevitable that
Not everything can be
not
paired.
everything can be paired in a good.
But we got almost, I mean,
Yeah.
except for these two who were achievers, high achievers.
Yeah.
Of course, we could try one more iteration and see whether there's a slightly better fit by
Yeah,
doing
so
some
because in the
exchanges.
beginning we were not looking at chemistry at all. So we could have looked at among all 3 subjects which 2 to select. It would have been a little more complicated to pair up. But I think this idea of grouping them first by total
Binning
marks.
them by total
binning
marks.
them and of course, we, as you said, we binned by the total and then looked at maths physics. Maybe if we had taken a subtotal of maths and physics, we would have found a better
match, better matching.
Yeah.
So what did we do? I mean, just let's reflect on what is the procedure. What method is this? What is this? Is this an algorithm? We want to make study groups. So what are we doing? I mean,
we are trying to find good combinations within a group of, in this case 30, could be any number.
Good pairs we are trying to find.
We are kind of good pairs.
But we are not blindly searching for all pairs, because if you take 30, again, as we saw last time, if you have to make all pairs, that's 30 into 30, 900 and divided by 2, because A and B, A compared to B, B compared to A is the same. So 900 by 2 will give you 450. So 450 pairs is a lot of pairs to look at. We are not doing that.
So we are initially grouping them so that we are only looking at pairs which
within totals being
within a close range of each other. In this case, we have.
So this binning thing seems to be a generic method, right? It seems to be a method of reducing the comparisons, because otherwise you get too many comparisons. So last time for date we decided to bin by month, right? So here we are binning by range of total marks.
And we could have used the binning in a different way. See, for instance, we could have really decided, so we argued that it is good for students to help each other mutually, but we could also have taken the bins and said that take the students with the highest totals and pair them with the students with the lowest totals. Because they will get the maximum benefit.
The lowest total will get the benefit.
Yeah, so still we are pairing across two bins, but in a limited way and not across everything.
Yeah.
So once we bin, I think we have different strategies we can use as to how to use those bins. And we also had some flexibility about choosing the bins. I mean, we decided on these 6 bins, but we could have chosen 8 bins or 4 bins.
4 bins.
Whatever.
So we said, okay, so we don't want to make all pairs, because that looks really, I mean, it looks that we are doing it without planning, right? Without much thought. So if you apply a little bit of thought, then we come to the idea that if you bin it, then the number of comparisons reduces, right? So we binned it, and then after we got 6 bins, and then in each bin we took all the cards, and then we again didn't compare. We did something. Even inside the bin we did something.
We knew that we wanted to pair across 2 subjects, so we separated into the groups where one is higher and the other is higher. So
one is high in maths and one is high in physics.
So then we had to only look at
pairs between the two.
These two.
So if you had 8, so let us say you had 6 or 8 in one bin. Again you split it into 4 each.
Correct.
So now you have to do only 4 into 4 comparison, 16.
Instead of 8 into 8, 6, 32
or something. So that way you bring this is a way to bring the number of comparisons down, isn't it? So you are trying to, the idea is to try and bring down the number of comparisons by doing something which is slightly bit more smart.
Yes.
Right?
And of course,
looking at
this is also an example, I guess, of a problem where there is no correct answer. It's not like adding up 20 numbers and getting the total where you know the total.
I mean, that is true. Here any pairing, I mean, so long as the pairing is reasonable, there could be many choices, many solutions for this. There are many possible pairings.
Decide what is the reasonable choice, and then according to that work towards a solution which is close to that, achieving that criterion.
But of course, there could be, if you try to measure whether the pairing is a good pairing or not, there could be an absolute best pairing in this also.
Yes, we could, for instance, have asked that the total should be as close to each other as possible, and the difference in the marks also should be as close to each other as possible.
So you could find the best possible pairing among all pairings.
Yes.
But that is it looks like a very complicated problem.
That would then require us to possibly look at all
possible pairings.
Because even here, there is no guarantee. We might have taken a 20-mark bin and everybody might have been in the same bin. So binning is not a guarantee that you will get a smaller number of comparisons, but it is reasonable to expect when you have natural data like this that they will be spread across a possible range of things. The other thing I think we should have realized is that we saw that there was grouping in the center. And
there are more cards in the middle.
Yeah, so
it's a kind of distribution.
We need not have even made the bins equal.
25. In fact,
so we could have said,
at the edges.
Yeah, at the edges we could have had a 50-mark bin and maybe had 10-mark bins in the bin. That would have made a finer
typically, I mean, there is, in statistics we learn that any distribution of marks will follow a kind of a Gaussian, some curve like this.
Towards the average it will be bunched and there will be fewer people at the extremes.
Extremes. So extremes you make the bins a little wider and.
Yeah, so if you want the bins to be of equal size,
equal in terms of number.
The width of the bins must be of unequal size.
Unequal size.
They must be narrower as you come to the populated part and wider. In the extremes you are not so fussy in some sense about the.
But you could do that dynamically also. You could start with assuming first you make into 4 bins, let us say, And if you find that some bin is becoming too large, you split it into 2 bins, then it will dynamically come.
You could do that also. That's right.
Right?
Yes.
So let's say our overall target is to get to about 6 bins.
And then you suddenly find, for instance, that half of them are fitting in one bin. Then you could take that bin and subdivide that 25 into say 5 mark bins or 10 mark bins or something.
So you could usually start with 3 bins or 2 bins even. 3 bins, and then after that you start dividing those bins which are large, you start dividing it further.
Yeah, and the good thing about binning is you can do a binning in one pass. You don't have to do this pairwise comparison. So if you have to do 3 times you repeat it, you're only doing a 3
times you're doing it.
Regardless of whether you have 30 cards or 300 cards, it's only 3 passes.
3 passes. But within a bin, separating again into high marks and high marks again is 1 pass.
Yes.
But when you compare, you are comparing. So there's a, for that comparison between the two,
you have to
do a nested iteration.
But we want to cut that number of pairings that we have to check explicitly down to a minimum.
Very small number. So here what are we doing? So basically we are doing 1 pass preparing data, some kind of preparation we have done. Once we are prepared, then after that we do, in the final run we are doing a nested iteration.
Yes.
Right? So we are doing, because to compare you need
Correct.
2 iterations, one inside another.
2 sets of preparation. So we do one overall binning preparation. Within each bin we do some again preparation of separating into which is higher. So if you combine this, there is one round of preparation. And then within each such group we do a pairwise. Good. So that's something worth remembering for the future.